In this video, we're going to be looking at the basic notions, and this is section 11.1. This introduces geometry. And in this video, we're going to be talking about linear notions, planar notions, other planar notions, angles, angle measurement, the types of angles, perpendicular lines, and a line that is perpendicular to a plane. We'll begin what geometry is by talking about three undefined terms, which are points, lines, and planes. Okay. Now, a point is just a dot with a no size or shape. So in this case here, you'll see three different types of points. Point A, and usually a point is going to be denoted with a capital letter, and also point B. And this safety pin has a point, which we can call point C. And then we have the line. Now, a line is always going to be something that extends indefinitely in both directions without end. And in this case, we can label a line as a line with a lowercase letter, like in this case, line L, for the center line of a road. And also, if you look down here, the line extends indefinitely, so we can use a lowercase letter with line M. Also, a line can be identified with 2 points, A and B. So we can say line AB. And also we use a symbol for a line, which is going to be, in this case, the line with the 2 arrows and then AB on underneath it. Or we can say BA. So we can name this as either line M or line AB or line BA. Now, a plane is a flat surface. It extends indefinitely without end. So like this table top can be an illustration of a plane, and is usually labeled with a Greek letter. In this case, Greek letter alpha will represent plane alpha. Another example will be plane gamma. Or we can label a plane with 3 points, A, B, and C. Okay, a line has no thickness and it extends forever in 2 directions. Okay. Given 2 points, there is one and only one line that connects those 2 points. So in this case, let's say we have those 2 points A and B. With those 2 points, for those 2 points, there is exactly one line that goes through those 2 points. And this will be it. Okay. So that's an illustration of a line. It has no thickness. It extends in 2 directions without end. So if P and Q are any 2 points, we can create a number line on the line PQ such that there is one-to-one correspondence between the points on the line and real numbers. Okay, so here's what another line looks like. We can label that with lowercase l in this case and say that that's line L. And then we can label this as line AB because A and B are 2 points that are on that line. Or we can say A and C, line AC, because A and C are 2 points on that line. Now this brings up another definition, collinear points. Collinear points are going to be points that are on the same line. In this case, line L contains the points A, B, and C. Points A, B, and C fall on the same line L. That means that those points are collinear. And also we can say points A, B, and C belong to line L. And then points A, B, and C are collinear, but points A, B, and D are not collinear because point D does not fall on that line L. It's outside the line, so That's why A, B, and D are not collinear, because we can't get all of those 3 points on one single straight line. Let's look at linear notions. Between is this. Point B, that's this point, is between points A and C on line L. Okay, that's what between means. They're between 2 points on that line. Point B is between points A and C, but point D is not between points A and C because point D is not on that line. Okay, because you have to have collinear, because point D is not collinear with A and C. Another linear notion would be a line segment. A line segment is nothing but a subset of a line that contains 2 points of the line and all the points in between those 2 points. Okay, so in other words, a line segment is nothing but a part or portion of that line. In this case, line segment AB. Here in this case, A and B are the endpoints of that line segment. Line segments always have endpoints. So here, A and B are the endpoints, so we can label this as line segment AB or line segment BA. Okay. Another type of geometric figure is a ray, which is a subset of the line AB that contains the endpoint, which is A, the point B, and all the points between A and B, and all points C on the line such that B is between A and C. In other words, a ray extends in only one direction without end, and it does have a single endpoint. And notice that we have to label this. Here the endpoint is A, and the point on that ray is B. We have to label this as ray AB and not ray BA. When we identify a ray, we start off with the endpoint and then a point on that line. The first letter is always the endpoint of that ray. So it's ray AB, not ray BA. Okay, let's look at some planar notations like coplanar. Okay, now here we have a geometric figure here with some points that are on the plane. Coplanar is this. You have points D, E, and G. They are coplanar. So in this case here, we have point D, E, and G. They're on the plane, so that means that those points are coplanar. Now points D, E, F, and G are not coplanar, because here's F way up here. That point F is in a different plane. So we can say points D, E, and F are not coplanar. Lines DE, DF, and FE are coplanar. Here's DE, DF, and FE. Those are coplanar lines. Lines DE and EG are coplanar as well. Here's DE and EG. And then lines DE and EG, here's DE and EG, are intersecting lines. That means that those two lines intersect at a point. In this case, that common point is E. So that's pretty much the notion with coplanar. Also, we have skew lines. Skew lines are two lines that do not intersect, and there is no plane that contains them. In other words, they don't intersect and are not in the same plane, like lines GF and DE. Let's see, here's GF up here. DE is on this gray plane right here. Those are not coplanar. Those two lines are in two different planes. They don't intersect and they're not in the same plane. Okay, the next definition is concurrent lines. Those are three lines that intersect at the same point. Well, three or more lines that intersect at the same point. DE, lines EG, and lines EF. Those are concurrent lines. All three of those concurrent lines intersect at point E. Okay, next is parallel lines. Looking at planar notations, parallel lines are two lines that do not intersect. In other words, those two lines have no point in common. In this case, line M is parallel to line N. And this is the symbolic notation for writing parallel lines, the two bars in between the two lines. Line M is parallel to line N. Okay, so know what parallel lines are. Those are two lines that do not intersect, and they are in the same plane. And here's some axioms about points, lines, and planes. There's exactly one line that contains any two distinct points. Okay, so if I have a line, let's say that's line M, that line has two distinct points, and I'll call it P and Q. That's what that axiom means about points. There's exactly one line that contains any two distinct points. The next one, if two points lie in a plane, then the line containing the points also lies in that plane. Okay, let's say we have a plane that looks like this. And we have 2 points, M and N, they lie in the plane. Then, if I draw a line through those 2 points, that particular line also lies in that plane as well. Okay, the next one, if two distinct planes intersect, then their intersection is a line. Okay, now I'm going to show this using like 2 small square sheets. I'm going to let this be a plane and this one be another plane. If those 2 planes intersect, that intersection is going to be that straight line. Okay, it might be hard to see, but here, those 2 planes intersect. That means that the intersection here is always a straight line. And also, there's exactly one plane that contains any 3 distinct non-collinear points. Okay, so here, with this plane, we got points M and N on the plane, and also we can have point P on that plane as well. They don't have to be on the same. They don't have to be collinear. Okay, those points lie on the plane. So here, with the plane, there's exactly one plane that can contain 3 distinct non-collinear points. Okay, a line and a point not on the same line determine a plane, which is what I just illustrated not too long ago. Here we got a point and a line. A point is not on that line, but here you got a line, and then you got that point that's not on the line. That can determine a plane. 2 parallel lines determine a plane. I did say that parallel lines do not intersect, and also they're in the same plane. And also 2 intersecting lines can determine a plane, because you have 2 lines that will intersect at the same point. So obviously you have more than 2 points. So that means we can come up with a plane from those 2 intersecting lines. Okay, let's look at other planar notations. Plane alpha is parallel to plane beta. Okay, as you can see, those planes do not intersect anywhere. Now, alpha and beta intersect at a line called line AB. Okay, and we did mention that you have two planes. If you intersect two planes, that intersection is going to be a line. In this case, line AB. Okay, so you can think of the intersection of two planes will be a straight line. Okay, and also line L is parallel to plane alpha. Okay, they're parallel, so that line is not going to intersect this plane. And here line L is in plane alpha. Here is line L right here, which we can also call line AB if we want to. That's in the plane. And also, this line L will intersect plane alpha at a single point called P. So the intersection of a plane and a line that's not in the plane would be the single point. Okay, and a half plane is this. Line AB separates the plane alpha into two half planes. Okay, next we'll look at angles. An angle is formed by two rays that have the same endpoint. And an example of this would be this angle right here. And I call this angle ABC. That's an example of an angle because you have two rays, which are ray BA and ray BC. The same endpoint is B. And those two rays are called the sides of that angle. So ray BA and ray BC are sides of the angles because those are the rays that form the angle. And notice that we can name this angle as angle ABC, or we can name it as angle CBA. Or we can name this as just simply angle B, or sometimes they may have a number where the vertex is. And in this case, there's a 1 there, so we can name that as angle 1. And by the way, the vertex is that common endpoint of the two rays that form the angle. So the vertex here will be angle B. So you can name an angle just by the vertex itself. Okay, adjacent angles are two angles with a common vertex and a common side, but without overlapping interiors. So in this case here, we have angle QPR. Here's QPR. That's this angle here. Now I'm going to mark off in this color. That is adjacent to this angle, RPS. Okay. That means that those angles are next to each other, as they have the common side and not only that, the common vertex. Here the common vertex, of course, is P. The common side is ray PR. And we can measure angles by degrees and minutes and seconds. And also the instrument that we can use to measure an angle is a protractor. So here you see the illustration of what a protractor is and what it looks like. Pretty much you're going to place the 0 on the on one side of the angle, which is here. That's side AC. And then you're going to read the measurement from the other side of this angle, from A, B, which is in this case 30 degrees. Okay, now let's talk about what degree is. A degree is 1/30th of a rotation about a point. 1/360th of a rotation. about a point. The minute is 1/60th of a degree, and the second is 1/60th of a minute. Pretty much with time, you've heard of minutes and seconds. Usually a minute is going to be 60 seconds, or 1/60th of a minute, well, 1/60th of an hour, and then the second is always 1/60th of a minute. Okay, let's look at some examples here that deal with our angle measurements in degrees, minutes, and seconds. Find the measure of angle BAC. If the measure of angle 1 is 47 degrees and 45 minutes, and the measure of angle 2 is 29 degrees 58 minutes. So in this case here, we're finding the measure of angle BAC, and that's this angle up here that I'm marking off. That's B, that's A, and that's C. And the measure of angle 1, that's the whole angle here. That's 47 minutes, 45 seconds. 47 degrees, 45. Should say 47 degrees, 45 minutes. Then the measure of angle 2, that's 29 degrees, 58 minutes. Okay, so here we have a whole angle that we know. We have part of the angle that's given to us, but we want to find out this upper part of the angle. So we're going to have to subtract these two angle measures. All right, now the way we're going to have to do this is this. We cannot subtract 58 from 45. So that means we're going to have to do a little regrouping. That means we're going to have to take 1 degree from the 47 degrees. You can have 46 minutes. Now you have to think of this. 1 degree is 60 minutes. So we're going to need to add the 60 minutes to this 45 minutes. That would give us 105 minutes. And then we can subtract 29 degrees 58 minutes from that. Okay, now 58 minutes from 105 minutes will be 47 minutes. And then 46 degrees minus 29 minutes will be 17. 29 degrees will be 17 minutes. So that's why they got the 17 degrees 47 minutes from. That's going to be the measure of angle BAC, which is this angle that I have marked off. So that's how you subtract angle measures using degrees and minutes. Now part B is to express 47 degrees, 45 minutes, 36 seconds as a number of degrees. Okay, now we got 47 degrees already. Okay, so for the 47 degrees, we've already got that. Now I'm going to convert 45 minutes into an angle measure in degrees. So in this case here, I know that 1 minute is 1/60th of a degree, because it takes 60 minutes to make up 1 degree. So I have 45 of them, so it'll be 45 times 1/60th of a degree. So in this case here, if you do 45 divided by 60, you're going to get 0.75. So we know we got 47 degrees plus 0.75. Now for the 36 seconds, now you're going to have to think of this. If we got 1 degree, that's going to be 1/60th of a minute, and 1 second is 1/60th of a minute, then that means this will have to be 1 over 3600ths of a degree. And the reason for that is I'm multiplying 1/60th times 160. Okay, because 1 second is 1/60th of a minute, and 1 minute is 1/60th of a degree. So I multiply these two to get 1 over 3600. So in this case here, if I do 36 times 1 over 3600, I'm going to get 0.1. 0.01. Okay, so that's where they got the 47 degrees. Then 0.75 plus 0.01, which will give you 47.76 degrees, which is exactly what I have here. Okay, so we can think of 1 second is 1 over 3600 of a degree. Okay. All right, now let's look at the types of angles here. On the left, you see an acute angle, AOB. An acute angle is any angle with a measure less than 90 degrees. Okay, so here the measure of that angle is less than 90 degrees. So angle AOB is considered to be acute. And then a right angle has a measure of exactly 90 degrees. So here angle AOB is a right angle. And you can tell it's a right angle because of the box that is at the vertex of that angle. That small box tells me that that angle is a right angle, and it has a measure of exactly 90 degrees. And then next you have an obtuse angle. On the left is an obtuse angle. That's an angle with a measure greater than 90 and less than 180. Here, angle AOB is obtuse because that's a wide open angle. Because it's bigger than 90, but it's less than 180. And then, finally, you have a straight angle, angle AOB. A straight angle is a measure of exactly 180 degrees. Another way of looking at a straight angle is that the line is a straight line. And in a straight line, the angle measure will always be 180 degrees. Next are perpendicular lines. Those are two lines that intersect at a right angle. Okay, so here we got two lines, M and N. So in this case here, this is the notation for saying it's perpendicular to. M is perpendicular to N. Or another way we can say that is that line segment AB is perpendicular to line segment BC. Or ray BA is perpendicular to ray BC. Or we can say line AB is parallel to line BC. Okay, now let's look at a line perpendicular to a plane. Let's say we have a line and a plane. A line perpendicular to a plane is a line that is perpendicular to every line in the plane through its intersection with that plane. Okay, so here's what a plane looks like here at the bottom. And let's say that AB is perpendicular to that plane. Okay, if that's perpendicular to the plane, then that means it's going to be perpendicular to every line in the plane through that intersection with that plane. Okay. And the next thing we'll look at is perpendicular planes here. Okay. If P is any point on AD, here's P on the point AD, in plane alpha, and S in plane B, plane beta, so that PQ is perpendicular to AD and PS is perpendicular to AD, then angle QPS is also a right angle. Okay? And then since QPS, the measure of angle QPS is 90, then that means that these two planes, alpha and beta, are perpendicular. Okay? And I'll say this again because you have point P on AD, line segment AD, and then point Q is going to be in plane alpha, and then point S is also going to be in plane beta. And that's in a way that PQ is going to be perpendicular to AD, and then you have PS also being perpendicular to AD. So that means we can say that angle QPS is a right angle because it has a measure of 90 degrees. Okay, last thing is a dihedral angle. A dihedral angle is formed by the union of two half planes and the common line defining the half planes. And a dihedral angle is measured by any of the associated planar angles, such as angle QPD. Here's QPD, where PO is perpendicular to AC and PD is perpendicular to AC. Okay, so we can say that angle OPD is a dihedral angle, as it's formed by two half planes and the common line that's defining those half planes. Okay, so that would conclude this particular video on just the basic notions of geometry.